Hi everyone. In this series of lectures on ordinary differential equation, in the first topic, I'll show you existence and uniqueness of solutions of first order initial value problems. And what is initial value problem? So this is a differential equation plus one initial condition. So starting with linear equations, we will move to first order non-linear equations, and we will talk about whether there exists a solution, if solution exists, whether it is unique or not, and we put appropriate conditions to see existence and uniqueness of the solution of initial value problems. So firstly, I am starting with the concept of what is called solution, and then we will move to existence and uniqueness of differential equation. So solution is a function of any differential equation, is a function that satisfies the differential equation on some open interval. For example, you can check y equal to x square. This function satisfies this differential equation x dy by dx plus x square equals to 3 of x, and you can verify it by direct calculation. Derivative of x square will be 2x, then x square. So, so this is sorry 3x square. So you can check that this satisfies the differential equation. So what is called solution? So this is a function which satisfy, means if you compute derivative and then you fit in the equation, you got that equation is satisfied. And so you can see here. So this satisfies this equation. So 3x square equals to 3x square. But if we have, let's say, if we have this equation x y prime, so y prime is dy by dx plus x square equals to 3x, and then you you can compute what is left hand side. This is 3x square, right hand side is 3x square, and you can say x square equals to x. So if and only if, so what are possible values? X minus 1. So either x is 0 or x equals to 1. So if you take this function y equal to x square, this satisfy this equation. So we say that this is a solution of this differential equation. But on the other hand, if you take second equation, this one, then this satisfy only for x equal to 0 or x equals to 1. So in case first, you can write here that, so for every x belongs to R, so this is a solution. but here only for two values which are 0 and 1. And what is the definition? So solution is a function which satisfy the equation on some open interval. So, but in second case, this is solution only for these 2 points. So there is no open interval. So what? So which one is the solution? So you can say first differential equation, this has a solution y equal to xk, but second differential equation don't have a solution because solution should be on some interval, not, or you can say discrete points, isolated points, they are not concerned. So we don't have any interest on these isolated point. So solution means solution on some interval that can be इंटरवल समझते हो ना ओपन इंटरवल ये हो सकता है ये पूरा रियल लाइन है ओके so in case 1 this is a solution but in case 2 this is not a solution and one term is also used here that is known as solution curve so the graph of a solution you can say in case first so this is y equal to xk so this will be a parabola so the graph of a of a solution of a differential equation is known as solution curve and there is one term that is also used that is known as integral curve so you can think that you have a differential equation then you have infinitely many integral curve corresponding to different conditions and when you specify one condition when you specify initial condition as a parameter then you got one solution or in other word so let us take an example let us say so we have this family of circles okay these are concentric circles and this is so this circle is an integral curve of differential equation y dash equal to minus x by y you can check just integrate it dy by dx so what you got dy by dx equals to minus x by y so y dy plus x dx equals to 0 and after integration what you got x square plus y square equal to constant and you can write that constant as a square okay so this circle is an integral curve of this differential equation and you know what is the circle this is and तो अब सर्कल को अगर फंक्शन देखोगे तो आपके यू कैन टेक टू सेगमेंट्स वन दिस वन एंड another one this one so what are two segments one is you can write and second one is you can write y2 equals to minus a square minus y square okay so you can say these अब देखोगे देखो ये तो फंक्शन नहीं है ना सर्कल फैमिली ऑफ सर्कल तो फंक्शन नहीं है अब हमने सोल्यूशन क्या कहा था, सोल्यूशन ऑफ ए डिफरेंशियल इक्वेशन इज ए फंक्शन, फंक्शन है ना। सर्कल फंक्शन क्यों नहीं है, ये रिलेशन है, फंक्शन नहीं है। बट अगर आप दोनों इसको सेपरेट सेपरेट लिखोगे, y1 and y2 these are functions, so you can say these functions, these two functions satisfy the differential equation. You can check, compute dy by dx, compute करके यहाँ फिट कर दो, just compute dy by dx. This function satisfy the differential equation on open interval minus a to a, but say this is 1, but 1 is not a solution curve of differential equation, since it is not the graph of a function. ठीक है, तो कहने का मीनिंग है जो इंटीग्रल कर्व है, सो व्हाट आर इंटीग्रल कर्व, दे आर रिलेशन, एंड फ्रॉम इंटीग्रल कर्व यू फाइंड सॉल्यूशन कर्व। सॉल्यूशन कर्व क्या है, वो फंक्शन होने चाहिए। जैसे ये रिलेशन है ना, सर्कल का इक्वेशन रिलेशन है, बट अगर आप दो सेपरेट पार्ट में देखोगे, अबव वाला, ये प्लस वाला, बिलो वाला, अलग अलग, तो फंक्शन समझ रहे हो, फंक्शन क्या होता है, व्हाट इज द डेफिनेशन फंक्शन, फॉर एवरी एक्स देयर इज यूनिक वाई, if you take any x there is a unique y। बट यहाँ पे अगर आप सर्कल का ग्राफ देखोगे तो क्या क्या दिखेगा आपको, आपने x0 लिया तो y क्या आया, एक तो प्लस a है, एक माइनस a है। ओके, सो दिस इज नॉट ए फंक्शन, बट इफ यू टेक टू सेगमेंट सेपरेटली देन दे आर फंक्शन। तो द सॉल्यूशन कर्व क्या है, दे आर फंक्शंस। एंड व्हाट इज इंटीग्रल कर्व, इंटीग्रल कर्व इज ए रिलेशन which contain solution curve, so you can say this is the bigger set। ठीक है, solution curve है, उसके अंदर आपके, so for this is integral curve, और उसके अंदर आपके जैसे ये सर्कल, पूरा सर्कल है, this is a integral curve, and this integral curve contains solution curves, and there are two solution curve, one is this one, upper segment, and another one is this one below, ये वाला। Okay, so you should not uh, be you should not have any doubt with the definition of solution. So just what is a solution of differential equation? Of course that function satisfy the differential equation, and this function satisfy the differential equation on open interval। ठीक है, and isolated points, if you say that this is a solution for only this point or only this point, so they are not of much interest and they are not known as solution। So I am starting with the first order, linear first order equations, then we will move to non-linear equations, so linear first order differential equations, and you can write any linear equation in this form: y prime, which is dy by dx, plus t is a function of x plus y equal to some f of x। So this is, or you can say this is d by dx plus p of x y equal to f of x. So first result in this direction that you have already studied in your college, but here I am going it. Uh, I am restating in context of variation of parameter, and this is perhaps first. You can say this is the first theorem, and I'm saying it. This is existence and uniqueness of first order linear equations. You can use any notation, but here I am using dy by dt, or I am writing y dash. So y is a function of t. You can write dy by dx, but I will write dy by dt. So let suppose p and f, they are continuous on some open interval a b, and let y be any non-zero or non-trivial solution of homogeneous equation, which is y dash plus py equals to 0 on open interval ab. Then the general solution of non-homogeneous equation y prime plus py equals to f is y equals to, let us say, to avoid any confusion, let y1 be non-trivial solution of homogeneous. Then y equals to y1, which is a solution of homogeneous, then constant plus integral ft upon y1 dt, and if t0 is any point in AB and y t naught equals to y naught, then the unique solution is given by y equal to y1 plus y0 divided by y1 at t0 plus t naught to t. Although statement looks bigger, but you have done, when I will write, you will understand. You have done in your college somewhere. So देखो P और F क्या है, coefficient है, right hand side है, they are continuous function on some interval, and y1, what is the y1? Y1 is a solution of homogeneous, so equals to 0 on some interval. Then it says that then solution of non-homogeneous, okay, non-homogeneous is given by this formula, y equal to this one, and if you have one initial condition, okay, so इसको हम बोलते हैं initial value problem, IVP बोलते हैं. what is called initial value problem. Okay, when you have one condition that you know the solution at t equals to t naught. Okay, so if t naught, so if t naught is any point and y t naught equals to y naught, and this is the solution of non-homogeneous one, then unique solution is given by this formula. अगर आपके यूजुअल कॉलेज वाला नोटेशन लो तो आप इसको सॉल्व करते थे, dy by dx plus py equals to q, वही चीज है. But here I'm going to write in it in different context, and this is called variation of parameter proof. So the variation of parameters prove this result. Variation of parameter is widely used. What we do in this method, firstly you solve the homogeneous. Okay, firstly you find the solution of homogeneous, then you find one solution of non-homogeneous, or you can say from the solution of homogeneous you will try to find the solution of non-homogeneous, and this process is called variation of parameter. So what I am doing to solve this equation, so firstly let y1 be the solution of this equation. And you know how to solve this one. How you find the solution? So this is dy by dt. You can separate the variable. So you have dy by y equals to minus pt dt. On integrating, what you got? Log of y minus pt dt plus some constant. You can write that constant log of c. So then you have y equals to c times e power minus pt dt, and this is the y1. So what is the y1? Denote this with y1. So y1 is a solution of homogeneous one. So the variation of parameters, shortly I am writing v of op. Okay, so this is variation of parameters. So the variation parameters suggests that we should take y equals to some function b as solution of non-homogeneous equation, which is y prime plus py equals to f. Okay, so firstly write the solution of homogeneous, say y1, and what we take solution of non-homogeneous, unknown function times y1. आपने दो वेरिएबल में रिजल्ट पढ़ा होगा, बट सिंगल में भी है ये. ठीक है, सो नॉन होमोजेनियस का सॉल्यूशन आपने क्या लेना है? सम अननोन फंक्शन टाइम्स y1, and then then fit in the equation. So y equal to that we you have assumed, and then we will try to find v. Fit that solution in this differential equation, then try to find v. Okay. So for this, first write y dash. So what will be y dash? V dash y1 plus product rule लगा दो. V dash y1 plus v y1 dash. Okay. So therefore, so what is y prime? V prime y1 plus v y1 prime. Y1 prime means dy1 by dt plus p, and y is v y1 equals to f. Okay. So then this is y prime y1 plus, you can take v common from second and third term. So y1 prime plus p y1 equals to f. Can you let me know what will be this term in bracket? Y1 is a solution of homogeneous one. Y1 satisfies this equation. So y1 dash plus p y1 equals to 0. होमोजेनियस का सॉल्यूशन है ना, तो ये बिग ब्रैकेट वाली टर्म तो 0 बन जाएगा. सो y v prime y1 plus v times 0 equals to f. So you got v prime f by y1. So this is dv by dt, you can say. And on integrating, what you got? V equals to integral of f by y1. Y1 is also a function of t, you can write, and then dt. Therefore, solution of non-homogeneous y equals to v y1, or you can write y1, and what is this? We fit the value of y1. Y1 is constant time this. Okay. You can add some constant here, constant k, and then y equals to v constant plus ft y1 dt, and here you can write y1. You can write constant, you can write constant c or k. We have written in proof this is c, and you can say this is some, so denote this constant as another constant k. Okay. So v y1. So this is the solution of non-homogeneous one. ये proof था first part. Now take initial value problem. Now take initial value problem. So this is differential equation plus one condition. So at t equals to t naught, we know the solution, which is y naught. तो वो सेकंड पार्ट क्या पूछा कि इसका सॉल्यूशन क्या होगा. सेकंड पार्ट यही है ना. Then solution of this one is given by this one. तो इसको कैसे लिखेंगे? you have solution formula which is given by 2. So, an initial value problem means you are starting with T naught. So T naught is starting point, and at T naught solution is Y naught, and then go further up to point T, and at T solution is YT. So then by formula 2, just integrate that equation from T naught to T. So this is Ft upon Y1, this is dt. Now use the condition at T equals to T naught, we have, so left hand side YT naught, right hand side Y1 at T naught, then C T naught to T naught integral with same limits. So when you are doing integral from same limits T naught to T naught, this will be 0. तो C का वैल्यू मिल जाएगा यहाँ से. So this integral will be T naught to T naught. So integral will be 0. So C is y at T naught divided by y1 at T naught. So therefore solution is yt equals to y1t. Constant C is now y at T naught divided by y1 at T naught plus T naught to T f divided by y1 at T. So this is called unique solution. So this provides the answer which you say existence of solution. You can say there exists a solution. Solution है ना ये, so there exists a solution. And second, this is says that uniqueness. There is no constant C. This is unique solution. And I hope you understand what difference between unique and existence. जैसे आप ये बोलते हो ये circles family of circles है, okay? And if you take A equals to, let us say take A equals to 1, then this is a unique circle. And if A is a parameter, you have concentric circle, ऐसे बहुत सारे circles हैं concentric. But if you fix that parameter A equals to 1, you got, let us say maybe you have this circle with radius 1, this one. And likewise here, we have shown that there exists a solution means you got a solution of equation with some constant or parameter. But if you fix that parameter, if you take particular value of that parameter and which is given by this formula, then a unique solution of this equation is given by this relation. Any doubt? Have you studied this equation before?
Yes, sir.
Okay. You know, अपने कॉलेज में पढ़ा होगा ना, कॉलेज में आपने इस फॉर्म में पढ़ा होगा. So maybe dy by dx plus py equals to some q. Do you remember that how you find solution of this equation? By writing integrating factor. Okay, you know how to write solution of this equation. Can you give me any idea? आप इसको integrating factor you multiply both sides with this one. Okay, just multiply both sides with e power p dx. So this is observation, you can say. And you can write left hand side as d by dx y times e power p dx. अब इसका डेरिवेटिव लिख सकते हो लेफ्ट में. अब देखो डेरिवेटिव करो बाई पार्ट. y का डेरिवेटिव dy by dx, सेकंड e फंक्शन एज इट इज. फर्स्ट टर्म बन गया. सेकंड में y एज इट इज, दिस y एज इट इज, इन डिफरेंशिएशन ऑफ e पावर p dx. तो वो क्या आएगा, e की पावर एज इट इज और इंटीग्रल ऑफ p, इंटीग्रल हट जाएगा, एंटी डेरिवेटिव p आ जाएगा यहाँ पे. दिस इज लेफ्ट हैंड साइड. एंड व्हाट इज राइट हैंड साइड? राइट हैंड साइड इज सेम q. So now left hand side become exact derivative. So on integrating you got e power equals to integral of q, and you can check that was our formula plus some constant c. But here I have given a sense that if you take, or you can write e power minus this on that on right hand side, then constant को पहले लिख रहा हूँ मैं, constant plus q e power p dx and then dx. Integral this भी है ना. So in that case, so e power minus, this was the solution of homogeneous one that I have written y1, and rest of the term is same. You can check e power minus px, मैं x को t लिख रहा हूँ, e की power minus, you can check here, e power minus, this was the solution of, or you can say this was the one particular solution of homogeneous one, e power minus. Okay, e power minus, that was the solution of homogeneous. So what we are trying to do, variation of parameter is applicable for first order, second order and higher order, and we will use this method many times. That's why I am, what you have learned in college, I am writing that thing in term of variation of parameter. And what we do in variation of parameter or in differential equation everywhere, firstly, if you have a linear problem, firstly you solve homogeneous, equal zero ले लो आप पहले. Okay, remove right hand side, take 0, solve this equation, find one solution, and then assume the solution of non-homogeneous y1 multiplied by some unknown function. और सेकंड ऑर्डर में आपने पढ़ा होगा, वहां हम ये लिखते थे c1 y1 plus c2 y2. यहाँ पे भी कांस्टेंट आ रहा है. in other words, you got a constant, replace this constant with some parameter. Okay, so assume that solution of non-homogeneous is that you replace constant with the function and say this is y1. So, or you can precisely, you can write, if you want to write it clearly, say this is y and say this is k times this is my y1. y1 भी solution ही है वैसे, आप चेक कर लो. इक्वल्स टू 0 है तो एनी कांस्टेंट मल्टीपल इज ए सॉल्यूशन. आप 1 2 3 जो मर्जी लो, दैट एवरीथिंग विल सेटिस्फाई दिस इक्वेशन. अगर e की पावर माइनस p है तो 2 टाइम्स p है, माइनस 2 टाइम्स, एवरी कांस्टेंट मल्टीपल इज ए सॉल्यूशन. सो रिप्लेस दिस कांस्टेंट विद फंक्शन and this can be taken as solution of non-homogeneous, and then try to find this function by fitting that substitute जो आपने सपोज किया है डिफरेंशियल इक्वेशन में फिट करो and try to find that function v, and that is the solution of non-homogeneous. और homogeneous के solution को हम complementary function भी बोलते हैं. आपने पढ़ा होगा ना complementary function. So, so what we do in chapter, in this chapter, we consider, so we take initial value problems for non-linear differential equation. So what I am going to take in this chapter, so I am writing dy by dt equals to f of dy with one initial condition. For example, I have this equation like uh, y dash plus y square equals to sine of t, sine of, let's say t sine of y, and y0 equals to 1. So this is a nonlinear equation, okay? Or I can write in that standard notation y dash equals to minus y square plus t sine y. So this is my f right hand side. Dy by dt equal to something, and that can be nonlinear. And we will talk about existence and uniqueness of the solution of this problem. And you know that you can solve a linear problem, but you cannot solve nonlinear. We don't know how to solve this equation. You have y square, so it becomes nonlinear. So I am going to take some examples to illustrate what is called existence, uniqueness, etc. So firstly, I am taking this example. Let us take, I'm taking linear problem. So consider initial value problem. इसको short में मैं लिखूंगा IVP. Okay, IVP, initial value problems. So consider this IVP, y dash equals to 2 of t with one condition, y0 equals to 1. So you can integrate. So this is dy by dt equals to 2t. लिख सकते हो ना? On integrating, what you got? Y equals to t square plus some constant c. And initial condition is when t equals to 0, y is 1. So this implies solution 1 है ना, 1 equals to t is 0. So you got c equals to 1. So therefore y equals to t square plus 1. And this is the unique solution. Okay. So you are finding unique value of the constant c, or you can say parameter c. So we have unique solution. Let us take, this is example, say A, example first. Let us take next example, say this is B. So in this example, I am taking t y dash equals to 1, sorry, y, and y0 equals to 1. And you can write t dy by dt equals to y. So dy by y equals to t dt. Sorry, dt by t. Variable separate हो रहे हैं ना. So on integrating, you got log of y equals to log of t plus you can write constant log of c. So y equal to c times t is a solution. Now use condition. When t equals to 0, y is 1. So this implies 1 equals to c. Solution is 1. C t equals to 0. So what you got? 1 equals to 0, which is not possible. So what you say? This IVP don't have any solution. So no solution of IVP. Let's take third example. Okay. So depending on the situation, you have either unique solution or no solution. And take third example. Let's say t y dash equals to y minus 1. This is initial value problem. Y0 equals to 1. So separate the variable dy by y minus 1 equals to t dt. On integrating, you got log y minus 1 t square by 2 plus, oh sorry, I have to dt by t, dy by dt by t आएगा ना. So you got log of t plus constant, you can write log of c just for simplification. So you got y minus 1 equals to constant times t. Now use condition when t equals to 0. ये नोटेशन है ना, y इज ए फंक्शन ऑफ t, तो जो y के ब्रैकेट में है वो t का वैल्यू है. ओके, when t equals to 0, y equals to 1. So fit here 1 minus 1 equals to c times 0. So 0 equals to 0. Okay, 0 equals to 0. So you can check example B and C. In example B, you got 1 equals to 0. And in example C, you got 0 equals to 0, which is true. Second में true नहीं है, third में true है. But you cannot find C. So what do you say? Infinitely many solution. Okay, we cannot determine C. So we have infinitely many solutions. Infinitely many solutions. Okay, I'll stop. Any doubt? So depending on the situation, either you have unique solution or you don't have any solution, or you may have many solution as you are unable to find the constant C. Okay,
Yes, sir.
okay, then see you tomorrow.